Up next, Neros. Please welcome Olaf Hichwa.
Hello everyone, I'm Olaf Hichwa, co-founder and CTO here at Neros. I've been racing drones since I was 11 years old, and ever since then, I've been obsessed with chasing the limits of performance, mostly through electronics design. I met my co-founder in a drone race, and we both found our way into startups, and we were just so disappointed by the fact that America, in all her might, is only capable of producing tens of thousands of drones per year. By way of comparison, our main geopolitical adversary, China, doesn't think twice about producing 50 million drones per year. Based on our drone racing background, we knew that FPV drones, first-person view drones, could have tremendous defense applications, but America wasn't making a play here. We decided to take our skill set of drone racing and apply it to building 30 racing drones, which we put in our suitcases and brought over to Ukraine. By bringing these systems to Ukraine, we not only got to get incredible end-user feedback, but we got to see firsthand what real wartime innovation and production looks like. By going around, we would have discussions with people saying, we want to build an FPV that does this, an FPV that does that, and they would immediately say, no matter what you build, if it's a strike system and a attritable system, unless you can make 5,000 of these every month, you're not having a big impact. And that was extremely alarming because I don't know anyone in America that's making 5,000 of these systems a month. We were just so obsessed, or so impressed by their obsession with scale manufacturing and vertical integration, we had to do something about it. Since that trip, we've been super consistent about iterating our design based on end-user feedback. We stood up an office in Kyiv where we have full-time engineers and customer support representatives, and we're constantly getting signals from end users and actually implementing that feedback into our product wherever they might be. Before FPV drones, the status quo of strike systems was you would have to get out of your entrenched position, run up, and then fire a shoulder-launched missile at a tank that would be just a few kilometers away, and of course you'd need line of sight to that tank. That's tremendously dangerous. With FPV, an operator can be underground or hidden and basically look through the eyes of a drone as they navigate it into a target and then actually strike the system. Not only is there a huge safety factor in not having to have line of sight, but we've increased the strike distance of one of these systems from just a few kilometers to 20 kilometers. Perhaps most importantly, FPVs have changed the price per kill from the price of a Lamborghini to just a few $1,000s per strike. Enter Archer, Neros' flagship product. Archer is a cost-effective FPV system built from the ground up using American-made components. When we started, there were no radios in America that we could buy off the shelf that cost less than the rest of the drone combined. So that was a deal-breaking issue. We went through the long process of building the core components, the radios, the flight computers here in America, which got us on DIU's Blue UAS list. Which enables any end user to use our system with direct authorization from the Defense Innovation Unit. Thanks to this American-made manufacturing, we were able to score a 6,000-unit production contract to supply these systems to Ukraine so they can defend the front line of democracy. I'm actually here to make another big announcement. Since that 6,000-unit production contract, we've been able to scale manufacturing significantly further. And just this week, we hit a new milestone. We are now producing 2,000 Archers every single month, shattering our previous record, making it the highest production drone by a monthly rate in America. So you might ask, how did two drone racing teammates from their parents' basement put together a system with this level of performance and manufacturability? A lot of our strategy actually relies on this vertically integrated set of core components. So we designed a suite of radios, 4 custom radios from the ground up to utilize American silicon, American production lines, and American manufacturing. We designed a flight computer, a motherboard, a BLDC motor driver, and this wasn't just high level, let's put the top-level specifications on this system. As an example for our motor driver, the PCB assembly, like the process of bringing the chips onto the board, is done in America. The bare board, essentially the wires that connects everything, is made in America. The packaging of the semiconductors is made in America. In addition to Archer, we're also building Archer Strike, which is the kinetic version of our system that has been designed from the ground up for definitive lethality with our partner Kraken Kinetics. The system features a modular warhead capable of a variety of missions, anti-personnel, anti-tank, and it is being live fired right now in the US of A. Well, that's my speech. Thank you very much, and let's keep manufacturing.